So while the tail section is all drying, we're going to go ahead and cut out this little rib, center rib for the wings. Make sure when you cut it out that the little tiny strips in here stay in place, because that acts as a spacer. Later they will be cut away, but this hole is basically going to be a hole where the wing nut that holds the wing on is going to bolt through once this is set up on the wings. So go ahead and cut this piece out, and then we'll start gluing that to the wingtip, or the inner wing side. So the cut out wing rib should like this. Should look just like that, and the way this goes is it should be able to fit underneath this little tab here in the back. It should fit underneath that and sit down like so. Should sit right down in there. And notice that these lines right here line up with where the screw is going to go to hold the wing on. So we'll have a wing glued on one side and wing glued on the other side. So to glue this onto the wing, I'm going to use 30-minute epoxy again, because it really helps to be able to work it for a while to get it lined up just right when attaching it to the wing. And it holds very strongly, a very strong bond, since this is the main juncture between the two, the two wing pieces that connect in the center. All right, so another little helpful hint. See, this piece is going to go on the edge of the wing, and eventually it's going to hold both wings together. And they said, make sure you line up the back as close as possible and the bottom edge. So you want to line up the back and the bottom edge as close as possible. Now, one extra step I did is I took my trusty little hand drill, and I've drilled 2 holes, one here and one here. That way, when I get it exactly positioned the way I want it, I can take 2 push pins, push the push pins through to help hold it in place until it dries. Generally, the push pins are pretty easy to get back out, even with using the epoxy. So that way I can hold this exactly in place without worrying about it moving around. So now I have the 2 push pins held tightly, pushed down really tight to keep this piece as close to the styrofoam as possible while it cures. Now, when the epoxy dries, it will, when it hardens, it'll kind of pull that together. So it'll pull it together even closer as it dries. Do notice that here's the hinge area, the deep hinge area, which matches where the hook goes, so that when we plug it into the plane, it will plug in this way and the wing will be facing the top. So now that the rib is glued on and dried really well, had plenty of time to cure, I'm going to use some very fine tip cutters to trim out the section where the mount bolt is going to go. So now with it cleaned out, you should be able to take the main wing nut that holds the wing on, and it should fit right down into the groove. So I've already got my epoxy mixed up, and what I'm going to do is put a thin coat all the way across here, trying to avoid the area for the wing bolt. Then I'm going to put a thin layer across here, let it dry for just a few minutes because it is 30-minute epoxy. Then I'm going to work these together so that they are perfectly aligned as best as possible. So once the glue is evenly distributed, then use a few 1, 2, 3 blocks or something with some weight to weight down the wings to hold them together while it dries. Make sure everything's perfectly lined up as best as possible. So once the wing dried, I went along the rib here and just put a thin coat of the foam tack, avoiding the area where the spar is going to go run across the wing for support on top and bottom, and avoiding the area for the mount hole for the screw to hold the wing on. And I did that on both sides, just a thin coat, just to give it a little extra strength there. And then the next thing I did is, because it's going to bolt the wing nut that holds the main wing on, or bolt I should say, is going to screw into this forward piece here. And we want to make sure that this fits through the area left open in the wing. Problem is, a little bit of glue and other buildup is going to be in there. It's going to be difficult to get the bolt in there, and we don't want to damage the threads on the bolt. So what I suggest is you get a drill bit about the size of the bolt, and just by hand run it through the hole very carefully to open the hole up, to be sure that the bolt then freely slides into the hole. So before attaching the tail assembly, what I want to do is go ahead and add some more waterproofing to the bottom of the aircraft, which has not been done yet. Now, they've talked about using tape. I'm not really much for using tape on an aircraft. I'd much rather use the clear material that's already been used for waterproofing on the sides. I just haven't had a whole lot of luck using the tape. So what I would suggest is, prior to adding the clear material to the bottom, is to go ahead and go over the sides again, and on all the edges, go around the edges as well, which have not been done yet, to kind of get the stick around the edges. Also, what I would suggest is very meticulously and carefully use an X-Acto knife, a nice new sharp one, and go around all these edges and kind of smooth it out just ever so slightly all the way around any high points, because when you're in the water or in the air, you don't want to have drag. So any pieces that stick up could cause drag, especially when you're in the water trying to take off. Once you're at that point and you're ready, what I'm going to do is I'm going to put on some more of this clear aircraft skin material, and I'm going to center this and make it so that it goes up the sides about to where the red line is, all the way around on both sides. I'm going to do it in several pieces, back, midsection, and then a few spare pieces to use on the rear. So now that the coverings have all been applied, I'm going to go ahead and put on the tail section. So one thing you want to do is dry fit everything, put it together, and verify that when it's fully seated, when it's fully sitting in the slot, that it's at a right angle when measured from the bottom. Because if it's not sitting at a right angle, you're not going to be able to get it into a right angle as it's drying. So for this next step, what we're going to do is, first you need to find the two larger round pieces of fiber, carbon fiber rod. And you'll notice that there's the two longer big ones, and there's the two smaller shorter ones. The shorter ones are your push rods that we're going to put inside the tubes to connect to the elevator control horn and the rudder control horn. So make sure those are set aside, don't use those. What we want to use is the two larger, long, round carbon rod pieces. And what we're going to do is, there's a notch right here in the center rib that we glued for both wing halves. And this carbon fiber rod is going to sit down into the foam, centered on this cutout, and centered on, it needs to be centered same length on both sides. And the way we're going to do that is, we're going to get a long straight edge and put the straight edge centered right in the center of the hole. And I'm going to use another ruler to measure, to make sure the left and right sides, while still centered in the hole, are basically equal. Then I'm going to cut a slot that's just slightly, equal on each side for this carbon fiber rod, about 2 to 3 millimeters deep, and make sure that it's a little bit longer than the length of the rod right along where the straight edge is going to be. And then I'm going to use some foam tack to tack that down into the groove. So now what you want to do before it's glued in is go ahead and insert the carbon fiber rod into the slot. All the way across, should be about even with the surface, maybe just a snug under, but right about even with the surface all the way across. Make sure that it fits in the groove really, really well. That also will help open the groove up just a little bit to help get the glue to squeeze down into the slot. When we're finished on this side, we will go ahead and duplicate the same exact action on the other side. So while that's drying, we're going to go ahead and cut out the remaining pieces, which are for the motor mounts, and get those ready so that we can start assembling the motor mounts once the wing is dry. So next thing we need to do is install the motor mounts. So the way the motor mounts fit is there's these two slots, and it needs to be assembled in such a way that the firewall housing that has a notch at the bottom, when you run the wires from your motor, that notch needs to be in the bottom. These are keyed so they can only go one way. So once you know which way they're going to go, I'm going to take them and then insert them. It's going to be the smaller notch on the top. Smaller notches on top, larger notches on the bottom. Same for both sides. Smaller notches on the top. And just slide into the slot. When they go into the slot, they need to go all the way back to where you can see that it meets the outer edge of the blade, of the wing. So once you see it's fully seated, you know it's inserted the way that it needs to be. Then, if you look at it along the wing, it should be kind of facing up slightly. Kind of the motor itself should be facing up once it's mounted. So once this is on there, nice and secure, what I'm going to do is use a little bit of CA just to tack it in place. Then I'm going to strengthen the joints with epoxy because I don't want any of the motors to go flying off of the plane. So while we're waiting for the engine mounts to dry, get out the remaining foam pieces, separate them and clean them up. This piece should also look similar to this piece with a notch. Make sure to keep the nice dome in the front in place, just like this. Also locate the two carbon fiber rods, the little thin pieces, because they're going to insert in here, and we're going to then glue them in with some CA glue. So now I'm going to add the little floats to the little vortex generators here. And I'm going to insert them such that this part that curves down lines up directly with the bottom edge here, and all across the bottom should follow that same area. And then I'm going to duplicate that on the other side. Got to get them going in the correct direction. And it'll go together kind of like this. Now, one thing that the directions caution you on is that the glue, this is a different type of foam, and depending what glue you use, it could destroy this foam. So I've done a little test with my CA. I'd love to use CA to just quickly, tack these on. However, CA melts these. So I'm going to use epoxy because epoxy should not harm the foam. It takes a little longer to dry. You can only do one side at a time. However, it will keep the foam intact. So now that the first pontoon has had some time to dry, it's a good time to go ahead and put a thin coat of epoxy on the pontoon for the other side and go ahead and finish this part up. So it should look like this one is finished. So before we attach the motors to the motor mounts, check the size of the bolts that they provide with the motor, or not the bolts, but the screws that tap into the wood. And mine measure about 2 millimeter. It says in the directions that if it's using the larger screws, these should be drilled out to approximately 1.5 millimeter because we don't want to split the wood. So using a hand drill, as to be very careful, next step is to go ahead and drill out all 4 holes on both of the motor mounts. So now I'm going to attach the motors. If you have purchased the same motors that I have, you'll notice it comes with these little collets that are in the bag, and these are not needed for this build or for these motors. What happens is that the motor or the propeller will sit right on top of this piece that's already here, this smaller piece, and it should fit just inside that. If you put the collet on, it won't fit. The propeller won't fit over top of that. So you fit it over top of that, and then a little rubber band, or actually a very stiff rubber band, will go from this little post over the propeller to this post to hold the propeller on. Which is kind of nice because then if you hit something, it can flex and not break the propeller, or worst case, the propeller will come completely off and you just get another rubber band and stick it back on again. So this time, I'm going to go ahead and attach both of the motors to the motor mounts with the wires hanging down towards the slot in the bottom of the motor mount. Okay, before we get too much further into hooking up the wires for the motors, we need to go ahead and put in or install the aileron horns for the control surfaces. Now, the thing about this build is that the slits for the horns are not pre-cut, which means we need to do that ourselves. And they need to be 20 millimeters from the inside edge, which is the same as saying 2 centimeters. And it needs to line up with the profile where we cut the slit. It needs to line up with the profile, such as this little piece, the back piece here, will line up right with the inner edge of the hinge area, like so. So we need to go ahead and cut both of those slots. So now that the aileron control horn slits have been made, and I can line these up where they need to be, make sure it can fold all the way up. The aileron can fold all the way up without the horn hitting. And the hole in the horn should line up just about over the center of the hinge area. So you can glue this with the welders, you can glue this with CA, or you could use epoxy, which is my choice that I want to use here. I'm going to be sure they get a really strong bond on these guys. So now the cockpit area, or I should say the access area into the fuselage here, it's a little bit wider than 2.5 inches. So in the directions, it talks about marking an area off. It's a safe area, which is about 2.5 inches wide, centered on the center rib. So I'm going to go ahead and make some marks there. Once the plane's assembled, you won't see those marks, but I'm going to leave the marks there to know this is where the safe area is, in case I decide to go ahead and mount the ESCs here in the center. I'm certainly not going to mount them outside the fuselage area because I do want to keep them out of the water and make it so that I don't have to have as much trim to get the plane balanced in flight. So note about the electronics. The normal directions show using plastic dip to dip and cover both the ESCs, as well as using some material similar to that to seal up the receiver. Now, one of the builds shows that the ESC can go like out on each wing, and I don't like putting the ESCs out in the wings. I did get extension cables for the motors so that I could put the ESCs inside the fuselage. I don't want them exposed, and since they're going to be inside the fuselage, I'm choosing not to use the plastic dip on the ESCs or the transmitter, because if it's inside the fuselage, it shouldn't be getting wet. If it does, I may change my mind and seal them up, but the reason I don't want to seal the ESCs is because the electronics in there, the transistors that control the motors, are going to get warm, and heat kills parts. If I totally seal this up, make it watertight, I'm also trapping heat, and that heat over time can kill the transistors and then burn out the ESC. So I'm going to kind of keep an eye on that when I start flying, and I'm definitely going to be flying in a lot of water, and if the inside of the fuselage does not get wet or damp, then I'm going to leave the ESCs alone and I'm not going to seal them. If I see that that is problematic, then I may go ahead and seal them anyway. So we'll see. Same with the transmitter. And the transmitter, I'd have to seal right up to the rear connector and seal right up over top the antenna cables. And again, just going to wait and monitor that situation. Now the directions also talk about something else here. There's two ESCs. So both ESCs control, electronic speed controls, they will control the motors. However, they also supply the 5 volts to the system to operate the receiver and the servos. Problem is, because we have two ESCs, that means each one of these has a power supply. You don't want to connect the power supply outputs together. Doing so can cause excessive current drain on the battery, which runs your battery out quicker. Or in worst cases, if the two ESC 5-volt outputs are not close enough, and they're going to have a tolerance on these outputs. They could be 5.1 volts or 4.9 volts, and if the tolerance is off enough between the two, it could actually end up destroying one or both of the 5-volt supplies. They're supplying power from the ESC. So in the directions, it says the gear channel, which is the second throttle channel, to remove the red wire, basically cut the red wire. Everything will still work fine when doing so, and the throttle control, which hooks into the first ESC, the right ESC for the right motor, that will supply the 5 volts for the whole system. So it's okay to go ahead and cut the 5-volt supply, which is the center wire on the second or left ESC. So I have shortened my motor extension cables. So what I'm going to try to do is make the connections here in this pocket that'll fit underneath little covers that go on top, and then run it down and along the wing where there's no ferrules or anything in the actual wing area. So the area that I've put the heat shrink, where I've shortened the wires, will be inside the area that's part of the fuselage. So that way it's just straight wire going straight over. I'm going to go ahead and cut a slit and bury these and glue them in with a little foam tack on both sides. So now I'm going to use some foam tack to put the left side bottom cover on over the motor. Foam tack will be fairly easy to get back off later if this motor ever needs to be changed out. So I'm just going to stick it on real quick and pull it right back off. I'm also going to wipe away any excess around the motor because I do not want any kind of glue getting close to or inside the motor area. So now we're going to repeat the process for the other side, doing the exact same thing. Run the wires right around over here. Notice this ESC is going to sit like this, and the one on the other side will sit basically the same way. And I'll just foam tack these down because, again, foam tack is fairly easy to get off. And then, so both ESCs will be sitting here and here when we're finished. So after considering all the options for mounting the ESC and the receiver, I've decided I'm going to put the receiver right here, kind of a center on the spar underneath, and use Velcro, or to glue to both the wing and to the receiver. That way the receiver can be removable if need be. And then the two ESCs are going to sit just inside the area that's clearing the cockpit area. And just going to use some foam tack to tack them down just like this. Then when I fold it in, I'll have to just maneuver the wires to get everything in when I bolt the wing in. I did Velcro in the receiver just in case I need to take it out again. And I'm going to use a tiny little bit of foam tack to also make it easy to remove the antennas. But some foam tack to hold the antennas down in place without getting any on the metal exposed areas. Just a tiny little drip of foam tack. Put that on both sides. So it's easy to remove if need be. So while I'm waiting for the glue to dry, I'm going ahead and do the windshield real quick. So the windshield is going to sit just like so. I need to mark all the mating areas. Let's make sure that's centered. And it's going to fold over. So now I'm going to use a straight edge and bend the windshield and the marks that I've already made. Bend that up. This one's easier said than done. I'm going to try to fit this before I do the next one, before I do the other side. does look like that side lines up okay. So what I can do is hook this, put this little bolt in here. This is going to attach to the magnet that was installed much earlier in the build. I'm not going to totally tighten it down yet, but let's just make sure this side looks good. So that side is in. So it looks like that is going to bend just about right. So I'm going to bend the other side. So if I've done this properly, it will snap right into the magnet on both sides. And if that works, then I'll go ahead and tighten the bolts up a little better. So let's take a look and see. And there we go. The windshield is installed. So now that all the electronics that has been glued down the other side of the wing has had time to dry, I'm going to go ahead and put the covers on the other side, the top side of each one of the motor mount areas. I'm going to use foam tack again to hold these on. Take notice that there are two different types of clevises and attaching rods that are eventually going to be glued into the carbon fiber push rods. So notice that the shorter ones are the ones that go into these clevises here, and they have a smaller insert area for the carbon fiber. And then you have the larger ones. These are the ones that are going to go in the ailerons. And of course, there's 4 of each one of these types. And notice these are a bit larger, and they extend out a little further and have the larger opening for the larger, short little aileron push rod. So while waiting for the glue to dry, I'm going to go ahead and attach the ferrules to one end of each one of our push rods, both the larger ones and the ones for the ailerons. So now the next thing I'm going to do is start hooking up the linkages to control both the rudder and the elevator. Now we've already glued one end of each one of these clasps onto the carbon fiber rods. Now if you'll notice, if you hold the smaller rods together and look all the way down here at the other end, you'll notice that one is longer than the other. The longer one needs to go to the rudder, which in this case is facing us on this side of the aircraft. So what I'm going to do is insert this into the tubes that we installed earlier from the cockpit area. So one thing to be careful of is that there's no glue, residues, or anything at all on the push rod, because if there's any glues or anything on here, it's not going to move freely inside the guide tube. So if you feel anything on there at all, make sure you remove anything that could be a hindrance to it moving in the tube. And then what we want to do is from the cockpit itself is go in and insert this through the tube. Okay, so now that the carbon fiber rod has been pushed through the guide tube, several things. First off, make sure you put a piece of tape or something to hold the rudder straight and keep the rudder as straight as possible. And then using a pin, temporarily put the other clevis onto the control horn for the rudder. Then what we want to do is we want to measure from the end of the control horn back 30 inches I'm sorry, measure back 30 millimeters or 3 centimeters basically to know where to cut the guide tube. Of course, we'll have to pull the carbon fiber rod back out enough to cut that because we do not want to cut the carbon fiber rod at this point. Now, the other thing we want to do is should have 2 of these that we cut out earlier, little guides, and the guide needs to go over the control tube, and there's a little hole already in the side made to be able to glue this in to hold the guide tube where it needs to be. Problem is, the hole in this is not large enough for the guide tube, so we need to use the end of an X-Acto to widen that out to get it to go over the guide tube. And we need to slide this on before doing anything else, so we don't forget that this has to be on there. Okay, so I'm going to slide the guide tube, or I'm sorry, I'm going to slide the push rod out of the guide tube far enough that I can trim back the guide tube without cutting it. And I'm going to make sure it's well out of the way. I don't want to take any chances of cutting that carbon fiber rod. Okay, now we want to measure back 30 millimeters and cut this piece. So now that I've cut that back 30 millimeters, I want to take the end of my X-Acto knife and clean out the tube slightly to kind of deburr it and open it up to where I snipped it off with the snips. Okay, then I'm going to use the push the push rod through again the rest of the way and just make sure it moves freely. So now we need to use either need to temporarily hook up the electronics or use a servo tester that's capable of centering the rudder servo, which is what I've done here. And then we want to hook the control rod up to the servo arm on this side. And there's some screws that are set up for attaching this, and we want to go ahead and screw this into the servo arm. So to attach the control rod or push rod to the servo horn, we're going to use this tiny little brass insert. You may have to remove the servo to be able to get it fully press fit into the clasp. So now with the servo arm attached for the rudder and centered, we want to hold the push rod right up next to the end of the ferrule here. And what we're going to want to do is trim it. Just be very careful. I want to trim it about right where the threads start. Because that should be about how far it's going to insert down into this ferrule. So you're going to line it up as best as you can. And then snip it off. Then you want to use a piece of sandpaper and kind of clean the end up around here a little bit. And then apply some epoxy or CA glue or whatever you'd like to use to hold this into place. And make sure the rudder stays centered and the servo stays centered for the rudder while going through the process. So be sure that the glue is dry before trying to connect the little support. And there's a little hole you'll see in the side that's made to hold the support. I'm just going to use foam tack once mine is set up and dried. So now that the rudder is finished and glued, I'm going to go ahead and repeat the exact same steps for the elevator. And then keep in mind, use the center hole in both the rudder and the elevator. Inside the fuselage here area, that the outermost hole is used for both. So for the elevator, while repeating these steps, one thing to remember, first off, make sure the elevator is perfectly level. So I've applied tape here and here to keep it perfectly straight. Then I'll just temporarily, again, center hole, put a little pin in there. We're going to cut this back 30 millimeters, which is 3 centimeters back, just like we did on the other side. Okay, so when the elevator is attached, it should look like so. Just have, again, a temporary pin in the center position to hold it in place while the glue is drying. And notice the support is not yet, the little support post is not yet connected, just hanging there. Same for the other side until it completely dries. Then I'll foam tack that in. When you go to the cockpit, they should both still be centered, both servos. So before moving on to setting up the aileron controls, I want to, and before gluing in the servos, want to open up one of the holes on the arm here. That is, the arm extension on the control horn for the ailerons. The outer hole, the little bolt that comes with the little clevises, fits the outer hole just fine, but doesn't fit the inner hole. And I want to be able to have the option to move it. So I'm going to go ahead and use a drill that's the same size as the first hole and drill the second hole out to the same size on both sides of the aircraft. Okay, so with the holes drilled out to match on those control horns, I'm now going to tack down, because everything's in place here for the rudder and the elevator. So what I'm going to do is go ahead and tack in all 4 servos using a little bit of foam tack. I'm just going to put a little bit, just a few dots, just to help hold them in place on each servo, because they do fit pretty snug. Before we move on to attaching the wings so we can do the elevator. So we can do the ailerons. Okay, so I have the foam tack now in place, just in a few places across the bottom of this one and across every one of them where the little connecting tabs are glued in. And I've done that basically on both sides the same way. So they're tacked in with the foam tack, which is easy to remove, or at least not nearly as hard to remove as CA or epoxy. So I've run into an issue while trying to finalize hooking up the push rods and the clevises for the elevator and the rudder, because when I took the pin out and tried to put the actual piece in that's supposed to connect these, it doesn't fit through the holes. So I need to open up these holes a little bit. So I'm going to go ahead and do that with a little hand drill. And I'm going to open up all 3 holes here and the 3 on the elevator, so that I have the ability to move these around if I want to reposition, change the control throw. So after drilling out the holes, I was able to get the clasp mounted properly for the push rod, and I also used a little bit of welders to glue in the piece that supports the push rod tube. That's for the rudder, and then did the exact same thing over here on the elevator. Again, center hole position, and also tacked in with some welders the little mount for the push rod. So the other thing I've done is I glued down the wires with some foam tack, again, which is easy to remove if I need to pull the wires back out. And I didn't want these wires hanging down because they would be sitting right in the compartment in this area, and I didn't want them to come down and interfere with the control horns on the servos. So this is how I currently have it set up for the wires. And what's going to happen next is we need to hook up all the electronics and get the 2 aileron servos centered with the electronics on, and then put the wing on. Once the wing goes on, it's not going to come back off real easy, because we have to set up the push rods for the 2 elevator horns, and they hook between the wing, which can be disconnected, and the horns on the fuselage. The horns coming off the servos on the fuselage, which also will have to have one end disconnected to get the wing back off. So we want to get everything prepared so when we button down the wing, we don't have to take it back off again. So you need to hook up the electronics, test everything, make sure it's good, check the motor directions, On a lot of planes like this type, you'd have an inverted propeller. So you'd have one that would spin clockwise and one that would spin counterclockwise from the pilot's view. However, in this case, both propellers are going the same direction, which means from the pilot's view, both motors need to spin clockwise, or if you're looking from the front of the plane, they need to both be spinning counterclockwise. If they turn the wrong direction, we simply just have to switch any two of the wires for the 3 wires that go to the motor, and that will switch our direction. One additional thing we need to do when setting up the electronics is we need to remove the windshield area, pull that out of the magnets, and then we need to cut a hole near, I'm going to cut it near the top up here to feed through the power cable that's going to hook to the battery. So this little Y splitter cable needs to come through the top up here into the top of the battery box to be able to be plugged into the battery. Okay, so you can see I have the slot cut and the battery plug inserted into the battery cavity, and the other two, the splitter that's going to go to the 2 ESCs, are sitting right here, which should have no problem feeding into these wires once we go to put the wing on. When hooking up the wires to the receiver, keeping in mind that the bind plug connector is on this side here, antenna is on the top. Basically, it needs to come together like this. So the very first wire here is the right motor throttle, right ESC. Then we have the right aileron is next. The next one after that is the elevator, rudder, left throttle motor, or ESC, and then the left aileron is last. So testing the electronics, the first thing I see is that the rudder is backwards. So if I give it left rudder, it gives me right rudder. If I give right rudder, it gives me left rudder. Same with the elevator. If I say down elevator, I get up elevator. So I'm going to have to go into my controls and switch both of those, but they are working. They just need to be switched. And then it does look like we have operation of the ailerons here. So we just need to flip that over and hook those up. So now I need to check motor direction. And looking from the front, whether the wing is upside down as it is now or right side up, either way, looking from the front, they should both be spinning counterclockwise. If not, then whichever one that's not spinning clockwise will need to have 2 of these barrel connectors swapped so that it'll go the correct direction. So make sure it's going the correct direction, and then we can go ahead and hook the wing on, and we'll start working on the 2 aileron pushrod connectors. So now that I have the wing attached, what I've done is I've taken some leftover wood pieces from the 2 sides of the framing of all the wood pieces we cut out, and I've taped those along the wing, on the wing tips, basically to keep the ailerons somewhat in line as best as possible with the wing, with the wing to keep it as straight as possible for hooking up the push rods to the control horns on both the servo and the aileron itself. So now they're taped into position. We can go ahead and start to hook those up. We can always fine-tune them by turning the clevises in or out as need be if we're off a little bit, but we want to get it as close as possible while the glue is drying when we set these up. So while attaching the aileron push rods, one thing to notice is the type of clasp we have here. It's kind of a ball joint, and it has this little piece where the screw is going to mount in here, and the screw will actually be tight. The screw itself does not spin. This whole little ball joint in here will spin and turn as need be. Make sure that the ball is centered inside the little groove here. Make sure it's not pushed all the way in or pulled out, because that should just pivot like a little ball joint. So what we're going to do is I've attached the end that we already glued the push rod to. I've attached that to the elevator control horn. I'm sorry, to the aileron control horn, and I've also hooked up the other end this is going to connect to. And what you need to do is same thing we did for the rudder and for the elevator, is that we need to determine right about, you can see there's 2 different sizes of this little tube that is made to hold the carbon fiber rod. And you want to go kind of right to where the end is, just in a tiny little bit from the end of the larger area. Snip this off, sand it, then remove this piece back off so that it can be glued on, and then hook it all back up while it's drying. Now that's if you're using epoxy or welders or something like that. If you want to use CA, you just push it in, hook it all back up, and drop a few drops of CA on it while it's inserted, because that's going to dry a lot faster and not give you any working time. Okay, so this side is fully attached. See, it was cut, sanded, and glued in. And you want to make sure that the this can rotate back and forth slightly on the little bearing to make sure that they're in the correct place. And just make sure that that stays centered until the glue is completely dried. Now we're going to install the vortex generators, which also has the little float assembled at the bottom of it. And I'll show what surfaces need to be glued in just a moment. This one's already completed, and a couple things. First, you want to make sure that this edge lines up with the edge of the wingtip as best as possible, and then while it's drying, just put a 45 of some sort to, or a right angle of some sort to keep this straight while it's drying. So to put the propellers on, you need to either get a special tool, or what I do is I just take one of these little hex-head screwdrivers that has a hole in it and use that to do it. It's a little more tricky, but it works okay. And it needs to be facing such that it's spinning counterclockwise for thrust. With the edge going this way in the direction it's moving. So I put that on, take the little rubber band, put it across the bottom, then take this like so, and bend it up. Kind of helps to have two people doing this. And it's on. And I just got to straighten it all out. And just repeat that process for the other propeller. It turns out that they're saying to go about 3.5 inches, another part of the directions, from the center, from the center of the wing back, about 3.5 inches. And that ended up bringing me, when converting it to millimeters, about 88.9, or just rounded up to 90 millimeters. So I set my balancing tool to 90 millimeters, and it was very tail heavy. So what that tells me is I can put a larger battery on here to be able to fly longer, get a larger battery. And in the meantime, I've had to add 5 little weights in here to help balance the aircraft out until I can get a larger battery. And these weights are 1/4 ounce each. So basically I've added 1 1/4 ounces to the battery compartment to be able to get the plane to level out at the CG point back from the wing. The wing recesses in a little bit, so from here and here, set just on the other side of where the aileron control linkages are, I'm 90 millimeters on the CG machine. So now just a few final things to do. Some setup on the radio to set up all the control throws and rates and exponential, and then we'll be ready to go. So one of the first things I always want to do is make sure to set up the throttle cut. Don't want to have the throttle accidentally turned on. So I use this switch normally. Let's see, throttle cut, switch H, okay. So in the process of adding the throttle cut,
It does not carry forward to the gear channel, nor does it carry forward to the left and right thrust when you do the enable switch, for the rudder input to the two motors to help with steering. So what I had to do is I had to go in here and add an additional throttle to gear mix. And in the throttle to gear mix, I put in my throttle cut switch for -100 and -100. So this will allow me to cut both the left and right motors with a throttle cut. However, it doesn't totally inhibit the left and right rudder input when the throttle cut is on. So it's best to go ahead and turn your switch to off to where that mix is not on when you're doing a throttle cut.
So for the last step is just setting up the rates and the exponential. So I'm going to go into the menu to DR and Expo. And first we'll do the elevator. So channel for the elevator. And I'm going to use this switch, which is switch D for my rates. And I'm going to do 3 rates, so it's a 3-position switch. I'm going to do full on with no 100% travel and 0 expo, and then I'm going to go, well, I'll probably add some expo to the full travel, and then the next one will be my 3D rates, and the last one will be my low rates or just sport rates. So we're going to start on the low rate setting. Okay, switch, toggle my D switch, and start with rates on 2. So for 2, all right, so I need to set the rates. So we want 45 degrees. No, we want 25 degrees. Double check that. Yes, let's see. Yes, elevator 25 degrees for regular rates. So elevator back. Hold the elevator back. Set my gauge to 25 degrees. Approximately right there. And then change the travel to get that rate. So right about there is 25 degrees. So we're looking at 50%. So let me set the other channel to the same, or the other direction to the same thing. So 25 degrees is about 50% for the elevator on the lowest rates. Then exponential, I want to set to 25% for the slower rate, the fun sport rate. Okay, then we want to go on the elevator to switch, and I'm going to put it all on the same switch. You can separate these on different switches, but I'm going to just put the rates all in one switch. All right, so now elevator to position 1, which is going to be 3D rates. And let's do the same thing. Except now we want 45 degrees for 3D rates. So 30, 45 is right about there. All right, same thing, elevator down. Come on. There, I think is about 45, 30, 40, yep. Okay, so that is 93%. I think I'm going to bring that down to 90 though. And I need to do the other channel to 90 as well. Or the other direction, I mean, not the other channel, the other direction. Okay, so I've got 90% rate for my 3D rates. And then expo, I'm going to do 45%. Feel free to adjust yours any way that you'd like. If you'd like yours to be a little less sensitive, you can always turn the expo up. Or if you want less aggressiveness, you can turn the rate down. Okay, then when we go into position 0, I want full rates, and I think I'm going to do 50%. Well, let's go ahead and do the same 45% expo on this one as well. Or let's do 35%. Make it really aggressive. Don't use that channel that much. Okay, so I'm going to duplicate these rates here for, let's see, the elevator. Yeah, elevator duplicates these rates. The ailerons will be a little bit less. So I'm going to duplicate these exact same rates for the, rudder. We've already done the elevator, so I'm going to go to the rudder and do the same thing. So in position, let's change this to rudder. Okay, so now we're in rudder. Position 1 is going to be 100% and 35 expo. Okay, then position, let's get the right switch set up first. So switch D, okay. I need to reset that, 35. Okay, and then switch position centered. Rate was, I need, what was it, 45 degree. So, set this to 45 and do full rudder. And it's a little bit high, so let's back it off a little. Try 90, see if that gets us there, 90%. And it looks like it does. Okay, so it's pretty much matching the settings for the elevator. So 90% left rudder, and we need to do 90% on right rudder. Okay, and then I want to do 45% expo for 3D position. Later I'll add voice to say 3D rates. Okay, and the last position, since the other was the same, assume this can also be the same as the, let's see, I don't remember what the other rate was. Let's see, aileron in low position, not aileron. Elevator was 50% and 25% expo on the lower rate. Okay, so let's go to rudder, do the same thing, 50%. And expo was 25. Okay, so all 3 rudder rates are set. And they exactly match the elevator rates. Okay, so now we need to do aileron. So select aileron, and then go select the switch first, so I don't have to redo this again. All right, so then go to the highest rates and keep that at a rate of 100, and expo was 35. Okay, then now mid rates. So now the question is, let's see, we want for 3D rates, aileron, we want 40 degrees. So we set this to 40 degrees. And
40 degrees. And seems like it needs to be a little bit more aggressive to hit 40 degrees. Okay, so to get 40 degrees, it's pretty much full travel. So for the ailerons in the 3D rate position, I'm just going to keep it right at 0. Or 100%, I should say. No deviation. But we do want to set the exponential to 45. Okay, so then we just need to do the low rates. And for the low rates aileron, we want 20 degrees. All right, so let me set the gauge to 20 degrees. Okay. Moving my gauge back to 20. Looks like about 55%. Okay, so 55% on low rates, and I want to set the exponential to 25. If you've not done this before, notice that the curve changes as you change the exponential. The higher the exponential, the further you have to push the controls, the lever to make a change in the control surface. And then the more you push it, the more extreme it gets. But it allows you to make finite moves, finite turns with ease. Okay, so all the rates are set up, and next we are ready to fly. Good bit of wind. See how it looks like it is leaning to one side.
That's very stable.
So I hope you've enjoyed our build video for the Twisted Hobbies Puddle Star. And the more I fly this plane, the more I like it. You definitely will enjoy. It's going to take some time to put together, but you're definitely going to enjoy this plane, especially if you have some water to take off and land on. The only drawback I have to this plane in this review is that if you get the wing surfaces wet, the little pores will hold the water, throw off your weight and balance, and you're going to have to take it out and dry it off. But so just be careful not to splash down too hard. But this plane, it flies great, and the more I play with it, you'll notice in the final flight video when I was in the field that I was flying a little squirrel in the air. Well, we had 10 to 15 knot winds, and I was trying to see if I could wait and could kind of get all the balancing set just right. It did pretty well for that amount of wind. So really hope that you've enjoyed the videos. If you had, please like them, and feel free to subscribe to our channel. We have a lot more builds coming your way. We got an F4U Corsair, a P38, a very large P38 with 3 large retracts. Have a very tiny little biplane. It's like a super, super tiny 3D backyard flyer. So we're going to have that build coming up, and a few other planes as well. And we have a surprise video coming for, it's not an airplane, but it does hover in the air. It has to do with water, and it's a scratch build using a lot of 3D printed parts. We're going to have a video about a 3D printer and using 3D printing for your hobbies. And that's all coming up. So feel free to subscribe to our channel, and I hope you've enjoyed these videos.